Hello, everyone. Thank you for attending today's webinar, FWA, Sweet Spot for BEAD Deployments, presented by Samsung. My name is Joan Wiseman, and I'll be moderating this webinar. I'd like to start off by introducing today's speaker. We have Dimple Singh, who is the Senior Professional Regional Operator for Samsung Networks. You can read her full bio on the left side of your window by selecting the Speakers tab. Just a few notes before we begin. If you would like closed captions, you can access those from the bottom right corner of the video player. This webinar is being recorded, and you will be able to watch it on demand within 24 hours after we complete here today. We would love to hear from you. During the presentation, if you have any questions, please submit your questions using the Q&A tab on the left side of your screen. Time permitting, we will cover as many questions as we can. All right, we're ready to dive in. Dimple, please go ahead.
Thanks, Sean, for introducing and having me here today. I'm glad to be a part of this webinar and looking forward to talk about Samsung's FWA solution. So let's get started. What I would like to do today is discuss about BEAD requirements and how Samsung FWA solutions can address those requirements. In our previous webinar, we talked about FWA relevance for BEAD and how FWA can help extend BEAD dollars to reach more and more households serving the underserved, where deploying fiber will be a challenge. Today, I will also briefly talk about standard-based versus proprietary FWA solutions, but focus of this webinar is on Samsung solution where I will discuss massive MIMO, 44R, and millimeter wave solutions. I will also talk about some of the key technologies used in FWA solution, what operators should expect from FWA systems, and why Samsung's FWA is a sweet spot for BEAD deployment. Moving on. In our previous webinar, we discussed the importance of last mile access with FWA and why FWA is relevant for the hybrid approach of FWA plus fiber. To double down on that approach, we did a 10-year TCO study on both a rural and a suburban CBG in the Seattle area, and we estimated the savings with FWA over fiber. If you look at for both of these CBGs, a three-sector FWA site was considered. It was an MMU site, which can provide that 100 by 20 service. And all the network components which are required to put that site, like tower belt, core network, and transport networks, all of was considered to build this site. For rural CBG, we could require one site which can cover these 200 homes with a 30% take rate and a 50% action rate on the suburban. And on the suburban CBGs, we required two sites where 433 homes could be covered with a 30% take rate and a 50% action rate. And in both the cases, what we have seen once we compare it with an FTTS deployment over a 10-year TCO, in both the scenarios, the savings over fiber is around 30%. However, and having said that, in a similar study of a rural CBG, we have also seen that the savings could be as high as 57%. So even though I'm saying it's 30%, the range can differ based on which area we are targeting for these FWA deployments. And talking about some of the stats about FWA, right? FWA had phenomenal growth in US market last year. If we look at Verizon added around close to 400K FWA subs in quarter 4 23 alone, and T-Mobile added around 2.1 million in the whole year. And this market is projected to grow up to 10 to 13 million customers by 2025. In fact, if you look at the CPE components, a CPE vendor component here, a lot of CPE vendors are entering in this space. As per GSA study, in 2021, there were around only 25 CPE vendors, but now there are around 35 CPE vendors in this space. So clearly, this market growth of FWA is significant, and it is growing day by day. Now, before I get into specific solutions, Samsung specific solutions, I wanted to touch base on proprietary solutions versus a standard based FWA solutions, right? If you look at the standard based solution versus a proprietary solutions, some of the points where standard based solutions could be more beneficial over a proprietary solution is number one, leveraging existing infrastructure. So, for example, with standard based solution, already deployed core network or a baseband can be reused across multiple radios, while proprietary solutions are going to be always a new infra requirement. Also, standard based solutions offer diverse license spectrum based solutions, for example, millimeter wave, while proprietary solutions can be very limited to a CBRS or out of a couple of other frequencies only. In fact, financial stability of some of these vendors who are providing financial solutions is a question in marketplace, and also end-to-end security could really be a challenge with these solutions. Um, and standard-based solutions also provide benefit of a stable supply chain, and many players are available when it comes to CPE. While when you look at the proprietary solutions, the CPE is always in a closed environment, and many a times cost of these CPEs is also a challenge for most of the cases. While we can compare the performance as equivalent for both proprietary and standard-based solution, but some of these issues which I just mentioned are definitely a food for our thought when it comes to deploying FWA with standard-based solution versus proprietary solutions. Now, moving on to Samsung's network overview and what Samsung is doing in this space, right? Samsung is a leader in 5G and a proven one when it comes to FWA market. Samsung was the world's first vendor to deliver FWA commercially to one of the leading USA operators back in 2018. And since then, Samsung has been part of many FWA networks globally and within USA. Regarding vRAN, Samsung is the only vendor that has deployed thousands of vRAN radios and leading in vRAN technologies. One of the other key differences between Samsung and the competition is to have in house chipsets and not be dependent on other chipset suppliers. And this can help greatly in go to market strategies and new product launches. You can always be the first for new product launches when you have your own chipsets, and Samsung has been doing that since ages. Samsung is constantly pushing the envelope to innovate the latest technologies, and Open RAN is a proof of it. Recently, Verizon announced completion of deployment of around 130K Open RAN radios, and Samsung radios are at the forefront of that deployment. Samsung has been deploying many first networks in the world, be it standalone networks or non standalone networks, millimeter wave networks. Samsung has all of it in its portfolio. In fact, Samsung's RAN portfolio is the best in class and is available across all 3GPP radio bands. We do have radios for all the use cases, whether it is low band or mid band or millimeter wave, and a very powerful baseband, which we call CDU50, to support all of these radios. Our millimeter wave is based on vRAN architecture and gets connected to the VCU. We are always pushing the envelope in adopting new technologies and constantly adding the features to our portfolio. We do have an unified AI-powered EMS system, which is unified across our RAN and core networks, which is very simple to manage and uses advanced analytics with AI/ML to generate user-defined KPIs and also drives a lot of network efficiencies. When it comes to operational challenge in the network, it drives the operational efficiencies. Now, moving on to the specifics of Samsung FWA solution, right? If we double down on the FWA solutions for BEAD, the focus for FWA deployments will be around CBRS bands, as most of the operators who are planning to deploy these networks will be using CBRS bands. However, we think that millimeter wave is also could be a potential for the operators who have the spectrum and want to deploy this solution. And Samsung has all of these solutions in its portfolio. For CBRS, Samsung has two products. Number one is 604064R, also known as massive MIMO radios. It is an antenna integrated radios and can provide very high capacities. And I'm going to talk about capacities in a couple of minutes here. Samsung's massive MIMO radios are 5G ready and supports both beamforming and MU-MIMO technologies. In the case of FWA, where many residential subscribers demand a high data rate, both MU-MIMO and beamforming technologies are will play a key role to deliver those high demand 100 by 20 data services. And MU-MIMO and beamforming can do it for many customers simultaneously. They can provide that 100 by 20 service to all the customers simultaneously. The second product for FWA deployments is 44R, which can also be used for medium capacity requirements. It's a conventional RU system and supports both internal antenna and an external antenna. Uh, the CBRS 44R product works across 150 megahertz of spectrum and supports the complete band for CBRS. As I said, another very interesting band for these deployments, which can be considered as millimeter wave, and especially for the operators who hold the spectrum in this space, right? For millimeter wave, Samsung has an AU product. AU is an all integrated product, which means radio, baseband, and antenna all are integrated together to make it a high compact deployment solution. And when it comes to millimeter wave, it is really not very popular to reach places, means it is not very great in providing coverage. But Samsung has a feature, extended range feature, which can extend the range of a millimeter wave up to 10 kilometers. And our millimeter wave solution can be deployed in both standalone and a non-standalone mode. Massive MIMO and 44R radios follow traditional RAN architecture and can be connected to a very powerful baseband CDU50. Our CDU50 is capable of both 4G and 5G simultaneously. It also supports FDD and TDD technology simultaneously. And millimeter wave follows vRAN architecture because it has the DU part integrated within the radio. It gets connected to the VCU uh, mm, for getting connected to the core network in the backend. And our millimeter wave solution can be deployed in both standalone and non-standalone basis. Also, the VCU can be deployed on any COTS-based hardware. We have tested with both HPs and Dell of the world. So any COTS hardware, we can deploy our VCU system. Now, I was talking about the capacities of Samsung solution, and now is the time to look at them. Talking about our massive MIMO 604064R product, which is also a key product for FWA deployments, right? This product supports across 150 megahertz of IBW, operates across the full band of CBRS. It is NR ready and can support 600 UEs per sector. Uh, the Samsung Massive MIMO product also supports 16 layers, MU-MIMO layers in downlink, and supports both beamforming and MU-MIMO technologies. So if we look at downlink MU-MIMO, imperfect or orthogonal beams can cause multi-user interference, and hence beamforming weight has to be chosen very carefully. If you look at Samsung's Massive MIMO product, it creates a channel matrix and it forces a zero beam towards the other users. So the target user will get the full beam and the other users get a null, basically, and it is called a zero forcing beam forming that reduces the interference in the network greatly and enhances the capacity of the system. If we look at the right side graph here, where I'm comparing the capacities of massive MIMO system over a traditional 44R and a system which probably have lesser number of massive MIMO layer. So if we compare at a 44R system, massive MIMOs can provide around 300% peak throughput capacity over a 44R. And if we look at a system which is having low number of MU-MIMO layers, for example, 8 layers, it can provide up to 150% of peak throughput capacity. So the gains of Samsung's massive MIMO system are significant. Um, we have seen some of the performance results in some of our operators' networks. And if you look at it in a near site scenario, which is around zero point 0.5 kilometers from a site with a 16-layer system, we can deliver 850 Mbps of throughput capacity across 20 megahertz carrier. And on a far side scenario, which is around 4.3 kilometers from the site, we can deliver around 689 Mbps capacity over a 20 megahertz carrier. And the beauty of the product is we do support carrier aggregation on top of this massive MIMO system. So the capacities will get doubled and tripled as you add more and more carriers. So for an 60 or 80 megahertz system, these capacities can reach into gigs. And I'm going to talk about those capacities soon in the later slide. Additionally, I also wanted to say that our massive MIMO system is capable of supporting multiple users, as we see 600 UEs per sector capacity, and it is very well capable of delivering the requirements of BEAD, which is 100 by 20, to multiple user simultaneously. It's a high capacity, high performance system, which we are deploying across operators within USA. Yeah. And moving on to the 100 by 100 requirements of FWA systems, right? When it comes to BEAD, I think most of the states and NTIA is focused on 100 by 20 requirement, but we have seen there are states which are also talking about 100 by 100 symmetric service requirements. And there's a notion in the market that maybe FWA is not capable of meeting these requirements. Uh, but that's not really true, and look at the table here, to address that issue. If we look at the table here, and on the left hand side, the massive MIMO 64 to 64R capacities are mentioned, and on the right hand side, 44R capacities are mentioned. One of the key benefit of NR, other than the high bandwidth, is basically to have a flexible configuration on uplink and downlink. And we offer two types of configurations: 8 is to 2 configuration, which is a downlink intensive service, for downlink intensive service, and the other configuration is 6 is to 4, which is used for uplink intensive services. And if we look at these capacities here, with the 8 is to 2 configuration, for an 80 megahertz system, our massive MIMO system can provide up to 4.5 Gbps capacities in downlink and 500 Mbps capacities in uplink. And for a 6 to 4 configuration, our systems can provide 3.4 up to 3.2 Gbps capacities in downlink and up to 1 Gbps capacities in uplink. So NR can clearly meet that 100 by 100 requirements. And if we look at the 44R capacities as well, they are pretty good. For an 8:2 configuration, we can reach up to 1 gig capacity in downlink, and for a 6 to 4 configuration, downlink is slightly lower, but uplink definitely we can reach up to 348 mbps. So if you look at the whole system capacities, while LTE FWA systems can meet 100 by 20 requirements, 5G FWA systems can certainly meet 100 by 100 requirements, for BEAD deployments, and definitely that puts these systems on the sweet spot for these deployments considerations. Yeah, and that's where I conclude my slides. This was my last slide, and we are open for questions now.
Wonderful. Well, we have some questions going in, and just so the audience knows, you can still submit any questions you have using the Q&A tab at the left side of your screen. We'll dive in. The first question is, what is zero forcing beam forming, and how does it support better thought capacity?
Yeah, Joan, thank you. So I'll just read the question again. I think it is you're asking about what is zero forcing beamforming technology and how does it address the requirement of capacities, right?
Yes.
Yeah. Okay. So as I said, there are always imperfect orthogonal beams, which can create multi-user interference. So what our system does is, while it is focusing the energy on one particular system, it is forming the null on the other users. So basically reducing the interference in the network, and the same resources can be allocated to multiple users, and hence it increases the system capacity, and that's where you see those high 4.5 gbps up to 4.5 gbps downlink capacities which Samsung systems can achieve.
Excellent. That's outstanding. The next question is, which CPE vendors have been tested with Samsung for CBRS?
We have tested with multiple CP vendors, and I think both of the chipset providers, basically Qualcomm and GCT chipset providers, we have tested. I mean, if I can name a few, we have tested with BECs, Codiums, Inseego. I mean, these are only a few I'm naming here, but we have tested with most of the CP vendors.
All right, excellent. Uh, what is the extension feature in 28 gigahertz that supports up to 10 kilometer coverage for 28 gigahertz?
Okay, it is called a PRAT extension feature. So I think the beauty of 5G is, in 5G the symbols can be configured flexibly. They can be configured as a downlink, uplink, or they can even be blanked. So what we do in this feature is we are blanking the symbols, and by minimizing the data rate, we are extending the coverage. So that's the PRAT extension feature through which we can achieve that 10 kilometers in 28 gigahertz millimeter wave.
Remarkable. So, how has Samsung seen SAS issues in CBRS commercial networks?
Uh, Not that we know of. We have operated with all the SaaS providers, be it Google federated. We have done the IoT, and most of our networks are deployed across these vendors. So not really, not many issues that we know of.
The next question asks, what type of antenna, like FPC chip, etc., are you using within the CBRS 64T64R? Is it a passive or active component? And this person is guessing active, but you'll tell us what it is.
Yeah, no, absolutely. It is active antenna. In fact, massive MIMO, the whole concept is about active antenna. So what it is done in a massive MIMO system is the radios and antennas are tightly integrated. We call them antenna element system. So these are active antennas which makes this massive MIMO systems.
Fantastic. So the next question asks, do you have any other spectrum solution other than CBRS?
Absolutely, and I briefly talked about millimeter wave in our in my webinar, but we do have solutions ranging, be it sub-6 or mid-band or C-band. Uh, we do have solutions across complete 3GPP band. You name the frequencies, and Samsung has it in its portfolio.
With the preference for the BEAD funding being on physical fiber, are states looking at wireless?
Yes, definitely. I mean, if you go and read about some of these releases which are there on their websites, some of the states which are actually advocating about FWA, and the clear reason about is the dollar money which is allocated isn't enough to cover all the underserved areas which are which has been come out, and that's where FWA clearly has a place. And even there are operators who are submitting applications considering whether it is only fixed wireless or a hybrid of fixed wireless plus fiber. So definitely FWA has a place for BEAD.
Are there any systems deployed today using 16 layers or 64 TRX, or is this capability offered as a future performance capability to future-proof a network?
No, absolutely. It is available today, and we have deployed networks which can offer 16 layers. It is not for future. We are doing it today and achieving those higher capacities in the networks.
Great. So assume FDD versus TDD can also play a role in meeting. So this person assumes, is asking you, can
Mhm.
FDD versus TDD also play a role in meeting the 100 millibytes per second BEAD requirement?
Oh, well, can you please read the question again, June? Sorry, I'm not sure if I understand the question very clearly.
Yeah, and maybe this person can expand on their question, but we'll assume
Mhm.
FDD versus TDD can also play a role in meeting 100 millibytes per second BEAD requirements.
Okay, I will try to answer it as much as possible. So FDD, it the Mbps requirements a lot depends on spectrum. Spectrum is key while delivering these
Mm.
high data rates, right? And in some cases, FDD spectrum can be limited, right? I mean, if it is a sub-6, then the spectrum could be limited to 20 or maybe 40 megahertz. So it all depends what spectrum the operators are holding, and but definitely, if an operator is holding an FDD and TDD, we can do carrier aggregation across FDD and TDD, and still the requirements can be met, if that was the question.
Okay. And if that wasn't, then please expand on your question. You have a couple more minutes. It looks like we have just this one more question. So anyone in the audience, if you have a burning question, oh, there one. That answered the question. Thanks. So you did answer his question.
Mhm.
So this is our final question today, and it's hopefully you know what it means, Dimple. It says
Okay.
10 kilometer millimeter wave or 10 kilometer wave. Does that?
Yes, it is 10 kilometer millimeter wave. I mean, if the question was about if the range, this extended range feature is about millimeter wave, then yes.
Okay. Well, wonderful. That was a lot of really fantastic questions. And anyone who's in the audience, you will have a chance to review this information because it has been recorded. Thank you to everyone who came here today and attended this Fierce Wireless webinar and for your fantastic and in-depth questions. Special thanks to Dimple for presenting and for Samsung for presenting today's webinar. As I mentioned, you will have access to a recorded version of our presentation here today within 24 hours, and you can use the same audience link that you used to join here today. You'll also receive a reminder email once that recording is ready. Thank you so much for being here. We look forward to seeing you at future events.